Let's try these word problems with linear systems here. So the cost to join an art museum is $40. So, you know, museums have memberships, right? $40 to join this museum. If you're a member, you can take a lesson at the museum for $2 a lesson. I guess they give you art lessons. Now, if you're not a member, you can still take the class. It just costs more. It's $6. So I want to write a system of equations that can be used to find the number of lessons where it's going to cost the same. Like, should I be a member? Should I not be a member? This is similar to, remember we did the cell phone? Which cell phone should I get? So what should I do? Should I join the museum to get the cheaper price? Or should I pay more? And it depends. Are you going to take a lot of lessons? Or are you going to take just a few lessons? And what is that few or a lot? You know, we need to find that number where it's kind of break even. So you have to write equations for this. So let's see. What if you're not a member? Let's start with that. If your cost is y, I'm going to let y be the cost. And what's x then? The number of lessons you take. So if you don't become a member, how do you calculate the cost?
Oh, cost times lesson.
Cost times lesson. So what's the cost if you don't join? $6. So your cost will be 6 times the number of lessons you take. $6, right? Now what if you do? What does it cost if you do join? Yeah? Well, what else do you have to do? You're right. Well, why? Why is my cost?
2x.
It's going to be 2x plus
40.
40. How many times do you pay that 40? One time, right? So you pay. So let's say we did one lesson. You're only going to take one lesson. It's $6, right? Or $42. So if you're only planning on taking one, what makes more sense? Don't join, right? Now what if you're going to take like 100 lessons?
Join.
That would be $600 this way. This one will be $240. So somewhere in between is that like break-even point. So we solve this thing. We know how to use substitution, and this is transitivity. If A equals B and B equals C, then A equals C. So 6x equals 2x plus 40. And you know how I have this graph here? I could have graphed this. As soon as I saw this 40, why didn't I say go and use the graphing method? What does 40 represent here? Y equals mx plus b. Where's 40? But you know, this became too hard to graph. I'm just going to use my algebraic method. So we'll subtract the 2x. And so divide by 4. X is 10. What's 10? What does that mean? Let's go back here. What's x? Number of lessons. So if I take 10 lessons, how much does that cost me? For which one? Either one. So 10 lessons is kind of that measurement you're going to use. Are you taking less than 10 lessons? Yes? Which one should you use?
No.
That one.
Yeah.
If you're doing exactly 10, does not matter. Maybe you join because there's maybe other benefits. But if you're going to take more than 10, you do this one. Okay? Word problems. I think I've got one more word problem here. A website hosting company and internet service provided offer the following cost option. It's the same kind of idea. So find the number of months where the total cost for the website hosting will be the same. You know, website hosting is you want your own web page, right? Okay. So this one says it's going to cost you $10, okay, but then it's going to be $21.95 a month. This one's like we don't charge any upfront fee, nothing, but then it's $22.45 a month. So again, how long do you want to keep this website around? If it's only for 1 month, probably cheaper going with this guy. But if you want it for a year, maybe it's better with this guy. So what equations? Let y be cost, and let x be the number of months that you're going to kind of keep this website around. So what would be the equation that describes what you would pay with this first one? Yeah, Ben? Well, let's be careful. Now, how often do you pay the setup fee? Once. And then what's this one? Every month. So be careful where that x goes. Okay, that's this guy. Now, what about this one? You don't charge anything. Yeah?
What about if you put the x in front of it?
No. And I tend to actually do it this way because it looks like y equals mx plus b. I guess if I wanted to graph it, I could. So what is the second one going to be? What's their cost? Yeah, right?
Y equals 22.45x.
costs nothing, right? They don't charge you any kind of upfront fee. And then you solve this guy. And substitution is awesome when you have two y equals, because it's the transitive property of equality. If a equals b, and b equals c, and a equals c. So 2195x plus 10, when does it equal 2245x? I'm like, oh goodness gracious. I'm going to subtract this way, so I get a positive number. And you know what I get here? 50 cents difference. Yeah, do that. What's 2245 minus 2195? 50 cents. Okay. And so now to get x by itself, you know what? This is easier with fractions. I know you don't believe me. 50.5 to half, right? Multiply both sides by 2. Yeah, I don't need to calculate. 20. What's what 20? 20 months. What happens in 20 months? Break even point. It costs the same. So if you want your website less than 20 months, you should probably go with this guy. But if you're going to keep it more than 20 months, you go with that guy. Right? So using these word problems. So I wanted you to see these because we are going to be using more word problems. But we can get into today, which is, I think, this one. Okay. So we're really just, we're working on the exact same thing. How do you find a solution to systems? I want to know, what's the xy value where both the lines are the same? So we know how to do that by graphing. I think we're better now at doing it by substitution. But there's another method, and it's called the Elimination Method. Yay, elimination. Woo! I wish I had a little firecrackers. Okay, so let's see how it works. Okay, so here's a problem that, oh, I wish I had this one. Suppose you open your wallet. Now, when I open my wallet, moths fly out. There's nothing in there. But suppose there's 15 different kinds of bills in there. And I don't know what kind they are yet. 15 different bills. And the thing I do know is there's dollars and $5. 15 different bills made up of $1 and $5 bills. And when I count it all up, I get $47. And I use a system of linear equations to find out how many $1 and how many $5 bills I have. Hey! All right, well, let's just have a little clue here. I'm going to let x be the number of $1 bills, right? Because that's what I want to find out. How many $1? And I'm going to let y be the number of $5 bills that I have. I kind of have a little guideline there. Oh, I know. What do I have here? Okay. So the amount, got me, $47. You know when you count money? How do you do that? If I know they're all ones and all fives, like how does that work? Huh? Wouldn't I take the number of $1 bills, the number, I have X of them, times $1, right? Plus the number of $5 bills I have, and they're worth 5, and what should I get when I do all that? 47. Isn't that how you count money? Yes. Yeah. And then I need a second equation though. How many bills do I have in total? So the number of $1 bills plus the number of $5 bills has to be 15, right? I mean, think about it. Do these make sense? No? Yeah. Which one does not? Which one? This one or this one? This one? That's how you count money. I've got so many $1 bills plus so many $5 bills. So these bills are worth 1 and these bills are worth 5. And you do this calculation, I know I have $47. And this one says, of the 15 bills, some are 1s, some are 5s, and I just got to figure out which way. Now once you do this, you got a system. And so now I have a system, so I have to solve it. So we could try and graph them. 47 big number, it's going to be a mess of a graph. I don't want to do that. Or I could use substitution, nothing wrong with that, I could. But let's try this other method called elimination. And talking. Let's just do it. The thing with it is check at the end. This is no different than the either method. Once you get a solution, plug them back in both. So that's the same. So here are my two equations that I have. What I'm going to do is I either add or subtract until one variable disappears. And what am I adding? This. Now if I add them, I get 2x's, right? Plus 6y. Did anything disappear? All right. Let's try subtracting. Now subtracting gets a little complicated because says you subtract this, you subtract that, and you subtract that. And I'm like, wow, why don't I multiply through by -1? Who says you can multiply both sides of the equation by -1 and it's still equal? Multiplication property of equality. So I'm going to do that. So I'm going to rewrite the top one, and I'm going to multiply the bottom by -1. Remember what that does? Sign flip, sign flip, sign flip. Everything becomes a negative because they're all positive. Now add. What is x? Minus x. X plus a negative x. It's gone, right? What's 5y and a negative y? And what's 47 and that becomes 32. So what's y?
8.
I remember what y was. Y was the number of $5 bills. So it appears I have 8 of those. And now how am I going to find how many $1 bills I have? Well, this one either equation, well, look, x plus y, I've got 15 bills, right? If 8 of them are $5 bills, how many of them are $1 bills? 7. Cool. That is the elimination method. You add till one eliminates, one variable eliminates. Let's do a simpler example. Oh, goodness. Okay, so I'm in the middle of the page here, and most of this I've written out for you. So you can look up here and just write down key things that will help you remember. 2x plus 3y equals 11. Negative 2x plus 5y equals 13. So you do have to have them in the same kind of form. Notice how this is standard form. Then this has to be standard form. I've got an x, I've got a y, equal numbers. Same form. And then I look at the x's and I look at the y's. Do I have opposites? And what are opposite numbers? What are opposites? Give me, what's the opposite of 10? And what's the opposite of -100?
100.
Positive 100. What's the opposite of 5x?
Negative
X. The idea is if you add them, you get 0. So do I have opposites here or here? I have on x. We're going to add. What's going to happen when I add? It will go away. So because that's 0. What's 3y plus 5y?
8y.
11 plus 13.
24.
Divide both sides by 8 using the division property of equality. Halfway there. Remember, I'm doing the exact same thing. Where do these two lines meet? I found the y variable. And now, same as with substitution, you're going to plug it back into either equation. Pick one. Doesn't matter. I'm going to pick this one. 2x plus 3, well, I think y is 3, equals 11. 2x plus 9 equals 11. 2x equals, subtract 9, yes. Oops, positive. So x looks like it's a 1. I think. It looks like if you were to graph these, they would intersect at 1, 3. How do I check the solution? Right, this. Take 2x plus 3y, substitute it. 2 times 1 plus 3 times y. Is that 11? Remember, it's a question now. Well, that's a 2 and that's a 9. I know it works. No number compared to number. That's how you do it. So it works in this one. You must check the other one as well. Negative 3 plus 14. Is that 13? Yes. I know with confidence I know that's the right solution. Yes. Oh, what an awesome question. She wants to know what happens, who says it's always going to work? And this is like, do you ever watch a movie and then they end it and they say tune in next week to find out what's going to happen? So I'm going to say tune in to next class. We're going to answer that exciting question. It's an exciting question. I love that question. So we're going to learn how to do this first, and then we're going to learn how to make them opposites. Great question. Okay? Now, it does say here sometimes you're with me because I feel like you're not. You're with me?
Yeah.
Okay. Sometimes you need to manipulate. What does that mean, manipulate? Change it around, right? One or both equations to make it easy to eliminate. So, I mentioned this before. They have to look the same. If you have y equals something x plus a number, be y equals something x plus a number. Same format, okay? Yes? Absolutely. Absolutely change the format.
Does it have to be just one or the other?
They have to match. Let's put it that way. So if you want to go standard form, they're both standard form. If you want to go slope intercept form, they both have to be that way. Yeah. Good question too, but give me a second. I'll answer. Hold that question. It's a great question. How do you know which one to use? I'll tell you that in a second. If you when you remind me, because I'll forget. You also, like in our example with the money, there might be a time you have to multiply through by a -1 to kind of answer Claire's question to get them opposites. Okay? So let's just do a couple of examples here. Look at this. Are these the same form? Well, this one is an x equals a y plus a number, and this is an x plus a y equals a number. They're the same format. No. Which way do we want to go? I don't know. I think I'll go, I know it's standard form. I think I'll add the y over, right? So if I manipulate, I want to change that guy to rearrange it. So if I have 4x equals -3y plus 2, you guys with me? Because once again, I hear a lot of talking, and then you're not going to know how to do it. Stay with me. Just a little bit more. Yeah. Now I'm going to add that 3y. Right? You're still talking. You're still talking. You're still doing it. Okay. So are these equivalent now? Can I do that? Can I just add 3y to both sides? Who says? Who says I can do that? Addition, property, and equality. That's manipulating. Playing around with these properties. Because what now is my second equation? Are they the same format now? Something x and something y equals a number. Same format. So now I can think about solving it. And a great question that I had was, how do you know which method to use? Graphing method, I rarely use it, I'll be honest with you, almost never, because look what this is pain. How do you graph this? You have to solve it for y. I'm going to have numbers that aren't integers to graph, and it's going to be hard. So I rarely do that. To use substitution, I would need to either solve this one for x or this one for y, and they don't look that easy to solve for x or y. Now to use elimination, is it hard or easy to eliminate a variable? These are not, so look at this. Now these are not opposites, they're sames. So I tend to look for sames or opposites. Because if they're the same, how can I make them opposite? How can I make them opposite? -1. Through the whole thing. And pick, it doesn't matter which one, pick one. So I'm going to rewrite this one. And this bottom one, I'm multiplying everything by -1. What gets multiplied by -1? Everything. And what does multiplying by -1 do? It flips all the signs. So that becomes a -5x, right? -1 times that. Negative that. This already is negative. So what happens when you multiply -2 by a negative?
Positive.
Do I have opposites now?
Yes.
You basically look at what's the easiest way to solve it. That's what I do. So, so 4x minus 5x, what's that? Well, what's better?
I was going to say, it'd be a plus and add negative instead of minus. Instead of minus, then minus 3 can be that.
So you know, here's the confusing bit. You are adding, even though it looks like you're subtracting. Because subtracting would be doing an opposite step. 4 plus -5x is really 4 minus 5x. So, right, what's 4x minus 5x? That is adding. 4x, let me look at it this way, plus a -5x, right? What's a plus times a minus? And what's 4 minus 5? So you're really adding here, trust me on this. So 4x minus 5x, negative x.
I'm talking about 3 and minus 2.
Oh, I'm sorry, I don't understand. Where are you asking?
3 minus.
This one?
Yeah, it's okay if you do a plus and
Don't. I think it's confusing. One sign always. Just give me one sign. A negative times a positive is a negative. It's a negative. Use one sign. Because it's easier to see. Now see how these are done? A plus 3y minus 3y is 0 equals 4. Negative x equals 4. I want negative x, I want positive x. All right, I get this down. I don't even see your notes. Where's your notes? It's called writing it down. How do I make this positive x? Or multiply by -1. I think it'd be a little easier to multiply, but you can. You're absolutely right. And what's going to happen? Flips. So remember what I'm doing. We get lost sometimes. What am I doing? Where's the point of intersection? -4 is the x value. How do you find the y value? Either one. Now be careful. We manipulated, right? Go back to the original. I may have messed something up here. I do it all the time. Go back to the original and see what you get. So pick either one. I'll pick this one. 4 times x, which I think is -4, is -3y plus 2, right? That's -16. I keep my y's over here, so I'm going to subtract that too. -18 equals -3y. Divide both sides by -3. Oh, what do I get? -18 over -3. I think this is the solution. How do I know I'm right? Plug them in both. Plug them in, plug them in, plug them in. Because that's the only way you know it's correct. I make mistakes all the time. All the time. Right? Okay, so this one I already did for you. It's on your paper. All right, this example, you're going to love this one. You ready? You'll love this one. If you've been sleeping the whole time, wake it up because you're going to love this.
Okay.
Who loves this? Yay, me too. Who just Yes. No. Are you an I love it? Or you don't love it?
No.
Yeah, you know what?
Which way? I'm indifferent. She's indifferent.
She's in crackers.
Well, I'm going to help you with this. First of all, there's kind of two ways to approach this. One is just deal with the fractions.
I don't want to work with the fractions.
All right.
I love fractions.
So you look at the x's, you look at the y's. Do I have any sames or opposites? Look for opposites first. Do I have any opposite numbers?
Yeah.
Yeah. This one, right? So I'm going to add 1/4 x plus 1/4 x. How many x's do you have? 2/4 x's. What's 2/4? You have 1/2 x. And okay, that goes away. And that's going to equal this thing added together, which is what, 2. How do you solve for x? Multiply by 2. And so x is 4. Remember, I want the x right there.
How is it 1/2?
What's 1/4 plus 1/4? 2/4?
Yes.
And what's 2/4?
One-half.
Oh, you're going to have to be able to reduce. All right, now I have to find y. Which equation shall I use? This one? Okay. She's saying use this one. So 1/4 x, and I think x is 4, plus 3/4 y. That's going to be -5. What's 1/4 of 4? 1. It is. So now I'm going to subtract that guy, right? I'm running out of room with this. 3/4 y equals -6. How do I get y by itself? Multiply by a reciprocal. Multiplication property of equality, so it's both sides. So there's my 1y. Okay. Cross, we're going to simplify here, right? So that becomes a 2. -2 times 4 is -8. I think that's it. So no problem, just work with the fractions. Option 1. Did anybody get heart palpitations during that? Like, oh, thank you. Yeah, one. We'll just point. Yeah, okay. So, method 2. Who wants to get rid of the fractions? I did forget to check it, and I should. Well, that's 1/4. That's a 1. Oh, this is hard. That does come out to 6. So that one works. That's 4 plus. That's nearly a minus. Oh, this is hard. What that is, the -8 goes here, that's a 2, -6. This is quite work, did it? Or I'm doing it wrong. I'm going fast. Probably because this is wrong. I should do that. So 3/4, I mean, think right there.
24 is 24 plus 3/4 of
What am I doing wrong here?
So when you do that, like 3/4 divided by like.
So I have to multiply that by 4/3, right? Negative 8, is that not the right answer? Yeah, so, I just went through a whole thing here. I did verify it, but man, fractions can be hard.
Yeah.
So, let's see if we can get rid of them, shall we? Everybody's watching, right?
Yes.
Rapt attention, this could save your life one day, your algebra life. Okay. Well, I don't know, maybe there's some kind of fraction emergency, you're like, oh my god. So, I'm just gonna put what we got, 'cause we know the solution. So what you do is you say, I don't like fractions, they make it too hard. I'm gonna look for, what do I wanna call it, the least common multiple? It's 4. Because if I multiply everything by 4, say, multiplication property of equality, what happens to these fractions? What? Say it louder. They do. What? Multiply it. Who says you can multiply it? Can we stop throwing things, please? Sorry.
It was Sam.
Multiplying through by this 4 knocks it out here, knocks it out here, right? I will be left with 1x minus 3y equals, multiply the other side as well.
28.
Yes. Fractions are gone. In fact, this 1x I can make it even a little simpler.
Wait, so.
Hooray! Yes?
So if you want, you can actually like reform one and then
Right.
you put parentheses and make 1 times and you can do your own.
Yeah, because it's the distributive property. All I'm doing is multiplication property of equality. I'm multiplying both sides by 4, because I can, and I'm doing it so I can knock these out. So what about this one?
What if they're not the same denominator?
What if they're not the same denominator? What if this was an 8? What would you multiply by?
Oh, 8 by 16 is 8.
Right? Well, you can, but I want the smallest number that'll work. So I would multiply by 8. But luckily they're all the same. So what happens to this one now? 4 times 1/4 x, right? Knocks it out, just an x. 4 and a 4 here knocks it out, plus 3y. Don't forget this side, right? Because both sides get multiplied, negative 20. Which looks easier to work with? This thing or this thing?
That one.
And look, I've got opposites.
Oh, they're not fractions.
They're not fractions anymore. Woo! Happy day.
Let's go.
Firecrackers, streamers, right? X plus x. This goes away. What's 28 minus 20? So what's x? Same 4 I got here, right? Plug it back in. Now, usually I say go back in here. Remember how much trouble I had? I am probably more likely to make a mistake. I would plug it in one of these. So let's see. 4 minus 3y equals 28. I just picked this one. You could have picked this one. Subtract 4 from both sides. Divide by negative 3. Negative 3. See what I got there? Which was easier? Which is less likely to make mistakes? Method 2. So if there's a ton of fractions and it's like, multiply through, get rid of them. Okay, that's an important point of this. Awesome. A couple to practice here. Let me just do some word problems before I turn you loose. Life is word problems, right? Now these are not on your paper here, so just look up. So you get your oil change, right? And here's how it works. Stop talking. There will be several word problems like this on the test for this. Pay attention. At an oil change center, you're charged a fee for the oil change. So we're going to charge them whatever it is to get your oil change. But you also have to pay for the oil they put in, right? The cars need oil, they take it out, they put in fresh oil. So you have to pay for the work they do, plus the actual materials, which is the oil. So let's see, the oil change for the car requires 5 quarts of oil, and it costs $22.45. The car that requires 7 quarts of oil costs $25.45. So I guess we've got 2 people doing this. Find the fee and the cost. So let's see what we got here. So I'm going to let X be the fee. it's like we charge you $20 to get an oil change, or whatever that fee is. And I'm gonna let Y be, the price of oil, what the oil costs. So let's see, this first person who got their oil change, I got the numbers here, where'd they come from? So they paid the fee, and then they got 5 quarts of oil, and it cost them $22.45. So you see where this is coming from, fee, plus 5 times the amount of oil we got. The second person, they paid the fee, they got 7 gallons of oil, it cost that. So do we see how we got these equations? That's the whole key with the word problem, is coming up with the equation. Because once you have them, now you're gonna solve it. And Noah's question, which is great, well, how am I gonna solve this? Do you wanna graph this thing? You see these numbers that are like decimals? I don't wanna graph that. I think that's gonna look hard. You could use substitution. I find personally, substitution takes a lot more steps. When there's more steps, I'm gonna make a mistake. I'm looking here, are there any sames or opposites for the x's and the y's? We got some sames, right? So how do I turn them into opposite if they're the same? So I'll keep the top one, or you can keep the bottom one, does not matter which one you do. When you multiply by -1, all the signs flip. If they're positive, they go negative. If they're negative, they go positive. And now I kind of add these together. This goes away. 5y minus 7y. Oh, 2245. What? -3? So let's see. So divide by 2, right? So y equals a positive number, right? 3/2, which is it's a number, right? It's a dollar amount. So I'm going to turn it into that dollar amount of $1.50. So it's $1.50 per gallon of oil, or quart of oil, right? Quart of oil. And then how are you going to find the fee? Plug it in. Pick one, it don't matter. X plus 5y, which I think is 1.5, equals 22.45. X plus, what's 1.5 times 5? I want to say 7.5. Is that right? Equals 22.45. Now do this for me. 22.45 minus 750. Make it 14.95. That's your fee. So it's $14.95 to get your oil changed, and it's $1.50 for a quart of oil. See? See how it works? That's a word problem. I may have one more note. Okay. So let's go back here. These are, where are they? They're on the bottom of page 2 here. Use the elimination method. Look for sames or opposites. Look at this first one. So you got the sames, or opposites rather. Add them, solve for y. Plug back in to find x. Verify solution.
Oh, are the opposites then you don't have to?
Yeah, just add it. It's easy. Just add them. Go do it.
Yes, that was right.
Now you should be, yes, I was right. If you plugged it into both equations, I think this one was a little tricky. This one is 9x plus y equals 2. This is negative 4x plus y equals negative 17. Different formats, and most of you notice, wait a second, they're different. How do I make them the same? If you want to just make a rule, put them in standard form, maybe that's a little easier. X plus a y equals a number. So this y is on the wrong side. So let me subtract it over. You get negative 4x minus y equals negative 17. Is that standard form? Let me rewrite the other one. Are they now the same format? Do I have opposites? Now I can add 5x equals negative 15. Right, and then you can finish this. Did anyone try this one?
I did.
Well, how would you do this one?
I got 30, negative 33.
Plug it in to get 9, 3. I plugged it into this one. You know how to do D? Because you look at that, it's like it's fractions. You like do that little screen, that thing, the screen here. Multiply everything by 5, and not only these, but this one too. Don't forget that one. Multiply everything by 5 down here. Don't forget the other side of the equation. see if you can get this one. It will still be a fraction there, but that's okay. You can work that out. Alright, give it a try, give it a try, give it a try. Are there other questions? Could we do this one? See? See, be careful because, you know, x and a y equals a number, but they're in a different order. I just turned this around. It became 6x minus 8y equals 36. I've got some sayings, but I want opposites. So multiply by a negative plus 8y equals negative 36, right? Flip, flip, flip. Rewrite the other one below it. And now I've got my opposites. Goes away, 7y equals whatever. Or 21, y equals negative 3. Plug in, you should get 2.
I got y equals negative 3, but I did it a different way. I didn't do the multiply by negative.
What'd you do?
All I did was I kept the numbers the same, and I just, from the 6x and the positive 6x, I just crossed them both out. And then it was negative 8y equals 36, and then negative
That's not
5
right.
equals 15.
That doesn't sound right to me.
And then you do errors.
I don't know, you got the right result?
Yeah, I got
Okay,
y
well, whatever you
equals
manipulated, it must have done it correctly.